Hi, I'm Bob Cabana, the Deputy Director of the Johnson Space Center and a NASA astronaut. I'd like to welcome you all today to Houston, Texas, home of NASA's Johnson Space Center and Space Center Houston. You're joining us at a very exciting time in the history of space exploration. As we speak, 2 robotic explorers are roaming the surface of Mars right now, a planet in our solar system some 249 million miles away. Now, when Spirit and Opportunity landed on Mars last January, we expected that they'd maybe work for about 3 months. Well, they've been studying the rocks and soil on Mars now for almost a full year. The knowledge that we've gained from their efforts is going to help us pave the way for the future exploration of the red planet. Mars is very much like Earth was in its very distant past. Understanding Mars, its history, its evolution, is going to help us better understand our own home planet. That's very exciting. But the most exciting part for me, and hopefully for you, is the goal of landing men and women on the surface of Mars by the year 2030. This means the lead scientists, analysts, researchers, and even the very first person to set foot on the surface of Mars may be sitting in your classroom today. 35 years ago, Neil Armstrong stepped out of Apollo 11 and was the first man to ever walk on the surface of the moon. Today, join NASA, the Johnson Space Center, Space Center Houston, as you take your initial steps in becoming the very first person to set foot on the surface of Mars. Enjoy the journey.
Okay, final countdown for the Where Are All the Little Green Men electronic field trip. Let's proceed with the checklist. Satellite uplink.
Check.
Facilities at Space Center Houston.
Check.
Television production crew.
Check.
Phone lines and email communication.
Check.
Classrooms all across the country tuned in.
Hey, Mrs. Watson, look at me. I'm on TV.
Sorry. Check. All classrooms are tuned in.
Okay, begin the countdown.
In 10, 9, 8, 7, 6, 5.
4, 3, 2, 1. Engine start and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
To our show, Where Are All the Little Green Men? We have an awesome program for you today, all about Mars. But before we begin, I want to introduce some of our students.
Hi, my name is Colin Harris. I'm in 8th grade at Burris Laboratory School in Muncie, Indiana.
All right, nice to meet you, Colin.
Nice to meet you, too.
And you are?
Hi Heather, my name's Ariana Anderson. I go to Burris Laboratory School in Muncie, Indiana, and I'm in 4th grade.
Nice to meet you, Ari. And guys, my name is Heather Paul, and I'm a project engineer that works here at the NASA Johnson Space Center in Houston, Texas. Now, these students and several of the others that you'll see in our program today have been here since Thursday, doing all kinds of awesome adventures and activities with Space Center Houston and the Johnson Space Center. So, Colin, what are some of the things that you have learned since Thursday?
I've learned a lot about space travel and that we plan to send man to the moon again in 2020 and man to Mars in 2030. And I've learned a lot about how space can affect the human body.
Awesome, and these are actually some of the topics that we're going to cover today in our program, right?
Yeah.
Now, have you had a good time?
Yeah, really
Sounds
good
like
time.
you had an awesome experience. Now, Ari, Colin just talked about all the kinds of stuff that I would think we would learn in school, you know, education stuff. Yeah. What did you do for fun?
We built water rockets that actually flew in the air, made habitats that you're going to see later,
Cool.
and made rovers that are actually going to move.
Wow, they're going to move? That's crazy. Well, I can't wait to see those. I know you guys can't either. Now, our program today is all about Mars. Why are we going to Mars? How are we getting there? And how are we going to live there? So I'm pretty excited. Are you guys ready to go?
Yeah.
Yes.
All right, let's go to Patricia and Kate.
Hey everybody, welcome to Space Center Houston. My name is Patricia. I work here at Space Center Houston.
Hi, I'm Kate Franklin. I live in Muncie, Indiana, and I go to Burris Laboratory School, and I'm 12 years old.
Excellent. And what we want to do is encourage every single one of you out there to participate in this show with us. We have a 1-800 line, and we want you to call in with your questions. We have a bank of experts here, some folks from Johnson Space Center and the Jet Propulsion Laboratory, and they are here to answer any of your questions, so try and stump the experts. So you can phone in or you can email in, go onto the website and email your questions in, and they will be answering those questions. And then also, we've had students do a poll online for our mission, and those results are in, and so we want to just thank the kids that did participate in that. And you know what? I think we have a call already, don't we?
Okay, yes, this first call is from Nicole from Indiana. Okay, Nicole, what's your question? Okay, you can ask your question now.
Go ahead, Nicole.
What causes dust storms on Mars?
What causes dust storms on Mars? I think I'm going to head this direction over to John. John, what causes dust storms on Mars?
Well, dust storms on Mars are caused very similar to the way they're caused here on Earth. You have differences in temperatures between hot air and cold air, hot air rising, and this typically happens in springtime when you're warming up the planet. So as the hot air rises and you start getting winds circulated, they pick up materials off the surface of Mars. Now, Mars's atmosphere is very, very thin, less than 1% of the Earth, so you can't really pick up big sand-sized particles like we do here on the Earth, but very fine particles like talcum powder is what the dust storms are made out of.
Very cool.
Okay, our next question is from Tyler from
Alabama.
From Alabama. Okay, Tyler, what's your question?
Tyler?
Can you please turn down your TV and then ask your question?
All right, well, we don't seem to have Tyler online, but we have a translation. How fast does the rover go? So, you know the answer?
Okay. How fast the rover goes, they don't go very fast. They go as fast as a really fast-moving turtle. So they go really slow.
And Dr. Eddie Tunstall, is that right?
That is correct. They travel quite slowly, so we always ask how slow do they actually travel.
Instead of how fast. Very cool. All right. Thanks for your questions. Keep them coming in and emailing questions as well. And we're going to go over to Heather. Heather.
All right, thanks, Patricia. Well, I have another student with me. Can you go ahead and introduce yourself?
Hi, I'm Molly Boylan from Muncie, Indiana. I go to Burris Laboratory School, and I'm in 5th grade.
Awesome. Nice to meet you, Molly. Now, have you had a good time while you've been here?
Yeah.
Great. Okay. So now what we're going to do first is we're going to talk a little bit about history, because it's important to kind of take a step back in time, figure out what we've done in the past to understand how we got to the discoveries and science and research that we've done here, and where you guys are going to take us in the future when we go to Mars and beyond. So check out this history video.
The exploration of space will go ahead, whether we join in it or not. and it is one of the great adventures of all time. And no nation which expects to be the leader of other nations can expect to stay behind this space mistake.
Oh, that view is tremendous. Get my feet up. Okay, I'm up. I feel like $1 million. I will pick it up. Live from the moon. 40 feet down, 2.5. Picking up the dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward, just into the right a little. Contact light. The Eagle has landed. That's one small step for man. One giant leap for mankind.
Hello, my name is Amy Ross, and I'm another engineer here at NASA Johnson Space Center. And with me, I have.
I'm Scout from Galveston, Texas. I'm in 5th grade and I'm 10 years old. I'm Andrew McGillivray from Minnesota. I'm 9 years old and I'm in 4th grade.
I'm Rick Lenahan. I'm a NASA astronaut and I'm 47 years old.
Very good. And we're going to go on and talk a little bit more about the history of Mars exploration. Andrew, have we been very successful in getting to Mars?
No, we have not. The U.S. has been sort of successful. Russia has been successful.
But not real often, yeah. It's hard to get to Mars, right? Sometimes we miss the planet, sometimes we crash right into it, okay? But we have had some successful robotic missions to Mars. I know that back in the late 60s and early 70s, we had the Mariner and Viking robotic programs. And then in the late 90s, we had the Pathfinder program. So what happened after that? What was successful?
The next successful mission to Mars was the Mars Global Surveyor.
Very good.
After that was the Odyssey and Mars Explorer.
Mars Express.
Mars Express.
Very good. So we've had several successful robotic planet projects to get to Mars exploration. Have you had much involvement with the Mars exploration, with the robotic missions, Rick?
I haven't had that much being in the manned side of it. I've done some shuttle flights and I've been involved in some of the pre-positioning or some of the planning for maybe the next Hubble mission, which might be robotic. But in terms of the Mars missions, I follow it like everybody else. I was one of those guys who was hitting the website at NASA headquarters when they went down, and I'm just real excited that we have a presence on Mars right now. It may not be a human presence per se, but it's telerobotic, and we can actually control things and move around and see things just like we almost would be if we were walking on the planet. So it's a really exciting time.
So astronauts haven't been to Mars yet?
No, we haven't made it there yet, but I'd be the first one in line if the opportunity arose.
Would you guys want to go to Mars?
Yeah.
Yeah, me too. Okay, well, let's go see if some folks have questions about the history of Mars exploration in Mars. Patricia?
Thank you. And we do. Who do we have?
We have Jamie from Indiana. Okay, Jamie, what's your question?
What?
What's your question?
I had a question. How many people are going to be the first people to walk on Mars?
How many people are going to be the first crew to go to Mars? Which one of our experts wants to answer that question? All right, Laura.
We're really not sure at the moment, but the real issue is taking enough supplies to support all of those people. So, and those supplies are really heavy and they're really big. Imagine taking enough water for 2 years. Imagine how much water you use in one day. So I imagine it'll probably be 4 to 6 or so. Well, probably won't be any more than that.
Great, thank you.
Okay, our next question is from Courtney from Oklahoma. Sorry, Courtney from Oklahoma. Okay, what's your question?
My question is what Mars looks like.
What does Mars look like? Let's go over to Jack. Jack, what do you think?
Well,
If you look at a lot of the images from Mars, it's very similar to what you might see if you were looking at pictures of the moon. Basically a large sandy landscape with lots of rocky terrain. As a matter of fact, if you look over to the Mars diorama, you can see images that were actually taken by Spirit and Opportunity. So it's a very accurate representation. So and it's very red. It's a red planet.
Red. Great, thanks, Jack.
Okay, our next question is from Chris from New York. Okay, Chris, what's your question?
How would we breathe on Mars when airtake only lasts so long?
Oh, that's an excellent question. How would we breathe on Mars when we only have so much air? Who wants that one? Laura's going to take that one.
We definitely have to take oxygen with us. The atmosphere of Mars is mostly carbon dioxide, so we'd have to take it with us. The way we do it, as far as having enough, is that we take a little bit with us, and then we keep recycling that. We remove all the contaminants, and then we recycle it so that it's breathable for humans. The same is true for water, actually. We take a limited amount of water, and then we recycle that over and over. So you're actually drinking your own urine, etc. But it ends up being very clean. So
excellent. Thank you.
Okay, our next question is from Heartland from North Carolina. Okay, what's your question?
Why does Mars have red dust on it, unlike other planets?
Why does Mars have red dust on it, unlike other planets? We are getting some awesome questions here. I'm going to go down to John at the end here. John?
Well, actually, the red dust on Mars is very similar to the red dust that we have here on Earth, and it's formed by the oxidation of iron. Iron's a very common element on Mars, and here on Earth we call it rust. And of course, what color is rust? It's kind of orangey. So that's where you get your color on Mars.
Excellent. All right, and folks, remember, you can go online to the website, and there you will also be able to ask questions and get more information. So remember to log online as well. We're going to head over and watch one of our Mars videos next. See you in a minute.
Okay, first segment of the mission complete. Let's get a status report. How are we holding up? We're structurally sound. Getting bombarded with lots of data looks like there's a lot more on the way to go. Great, but how are the classrooms across the country holding up? All the readings I'm seeing in these gauges indicate heavy classroom involvement. Lots of great activity out there. Sounds like we're progressing nicely on this mission. Are we ready to step it up a notch? We've got lots of ground to cover today. I think so. I'll go ahead and activate the next segment. Okay, ready hosts, ready students, activate. Why go to Mars? Segment activated. Back to the show.
That's a good question. Why do we want to go to Mars? Scout, what do you have to say?
Well, we might want to look for life, water, and all sorts of different things.
Okay, those are two good things, reasons to go to Mars. Andrew, why would you want to go to Mars?
I think it would look cool, and it would be fun to see if there was life or not, or water on Mars.
Okay, and why would you want to go to Mars, Rick?
I'd have to echo this gentleman's comments here. I think it would be cool. Humans like to explore, and our history is about exploration. And you could trace back the roots all the way from our country, Christopher Columbus discovering, the early pioneers discovering, and it's just a continuation of us going out and discovering new planets in our solar system. So Mars is the next logical step for people, and we may someday live there after we go to the moon.
Yep, we're curious. We want to know what's there. And are there little green men on Mars, Andrew?
If there are, we haven't discovered them yet, and there might be, but we haven't seen them apparently.
Oh, okay. And I know Scout's got a theory about life on Mars. Scout, what's your theory?
Well, there's this really deep crater called Hell's Basin, which it has a low enough pressure to contain water without it boiling away. And so that might lead to having life.
Okay, very good. Well, we actually have a question right now. Michael from North Carolina. Go ahead, Michael, ask your question.
Okay, I was wondering how long it will be until we live on Mars.
How long will it be until we live on Mars? Well, Andrew, what do you think? How long do you think it'll take before we can live on Mars?
I don't know. It will take a long time. That's all I know.
A long time. Rick, do you have an idea?
Well, I would like to think that these guys right here may be the age when they're grown up. Maybe they'll be the ones to go to Mars. Maybe a little bit younger. But I hope it would be nice to think that within the next next 50 years or so, that people might be, if not living permanently on Mars, at least attempting trips there and colonizing the planet.
That is the plan right now for our exploration program, is to have people on Mars within the next 30 years or so. Okay, and Janine from Indiana has our next question. Go ahead, Janine.
I was wondering, is the temperature on Mars real hot or real cold?
She wants to know if the temperature on Mars is really hot or really cold. What do you have to say, Scout? Do you know?
Well, the average temperature is about minus 81 Fahrenheit. And it can usually get up, it might be able to get up to 68 degrees Fahrenheit, but usually it's around minus 68.
Okay, so you need to take your winter coat, don't you? Yep.
It's cold.
Yeah, it's pretty chilly. Okay, Rachel from Indiana is our next question. So go ahead, Rachel.
What kind of qualities if you ever send a robot to Mars, what kind of qualities would it have to have?
That's a good question. I'll probably send that over to our bank of experts. They want to know what kind of qualities a robot going to Mars needs to have. And I think that's an excellent question for Dr. Eddie.
I think so too. Dr. Eddie, what kind of qualities does the rover have to have when it goes to Mars?
Well, for the rovers to operate on Mars, they have to have the ability to drive around on Mars safely. And they also have to have certain science instruments with them in order to be able to investigate the geology of the sites that they visit. So they have to be able to drive around on their own because we can't communicate with them like remote control. There's about a 20-minute time delay between when we send them commands and when they actually send us back information to tell us how well they did those commands. So they have to be able to do a lot of stuff on their own using science instruments and the ability to get around.
Excellent. Amy, back to you. Brady from Oklahoma has our next question. Go ahead, Brady.
Hi. How big are your spaceships?
How big are our spaceships? Well, right now we have the space shuttle, and that's the one that we can use to put people in right now. The Russians also have some spaceships. They're mainly capsule kind of vehicles. We don't have any spaceships ready to go to Mars, though. So I don't know how big they're going to be. Do you have any ideas? Pretty
No,
big.
that's a good question. They'd have to be bigger than what we have now for long duration flight because we probably would have a larger crew. The shuttle is about the size of a DC-9, and if any of you know what a DC-9 is, it's a commercial airliner that you might have flown on. In terms of living space, though, inside, it's pretty small. There's not a lot of room. We can get up to about 7 people there, but for short periods of time. For Mars missions, we may have that size of crew, maybe a little bit bigger, a little bit smaller. We don't know for sure yet, but we're going to need a lot more living space and obviously a lot more room to house food, air, maybe hydroponics to grow food for the missions. So they will be quite a bit bigger than the spaceships we're used to now.
Okay, very good. And remember, there's more information on the website if you want to go learn more about the vehicles to go on to Mars and anything else that we're talking about in today's program. Okay, Matt from Florida has a question now. Go ahead, Matt.
What would happen if the astronauts run into aliens on Mars?
What happens if astronauts run into aliens on Mars? What would you do, Andrew, if you ran into an alien on Mars?
I would try to take a specimen to bring back to laboratories or something so they could study it.
What if a Martian came to Earth and just grabbed you as a specimen? Would you enjoy that?
No, actually, I probably wouldn't.
You probably wouldn't. You'd say, take me to your leader. I think that's what you need to say. What would you do, Scout, if you ran into an alien?
Well, first, of course, I'd make friends because, well, who wants enemies?
That's right.
After I made friends, I might ask if they'd like to come on a trip to Earth so the scientists might be able to check them out. So then they're friends and they don't get worried because they know who I am and stuff like that.
Okay. I think maybe Rick might have met aliens. He's been in space. What would you do?
Just the people I've flown with, I think. When you wake up in the morning at first. But no, we never have really met any aliens in space. And again, when we go to space, we're not that far away from where we are right now, right? We only go up a few hundred miles. So we haven't really gone out into deep space yet. And who knows, maybe someday when we do, we may meet people from other planets.
Okay. Now we're going to talk about another reason to go to Mars, and that's exploring the geology of Mars. Okay, on Mars we have this big mountain. What mountain is that, Andrew?
The name of the mountain is Olympus Mons.
Olympus Mons. That's the biggest mountain on Mars, right? Well, do we have mountains on Earth?
Yes.
Yep, we do. What else do we have on Earth that we have on Mars? Scout?
We have craters, and so does Mars have craters.
That's right. What else, Andrew?
We have valleys on Mars
Okay.
and on Earth.
Okay, so like Valles Marineris and the Grand Canyon. Okay, so there are a lot of things that are the same on Earth as on Mars. And so if we can go and study the differences and the similarities, we can learn a lot about how both planets formed. So that's one of the reasons we want to go to Mars. Okay, now I think it's time to go back to our bank of experts and see if there are more questions for them. Patricia?
Thanks, Amy. Actually, we are going to check in on some students who have been drawing some crew patches. And all of you folks out there know that every astronaut and in their mission, they have a crew patch that depicts what their mission is all about. So hopefully you folks out in your classrooms have been able to draw some crew patches as well. And we have some students here from Fisher Elementary, and they are going to show us what their crew patches are and talk about that.
Thanks, Patricia. I'm over here with Fabian and Melanie from Fisher Elementary, and they have offered to share their crew patches with us. And they were told to tell us a little bit about what they would do if they were to take a mission to Mars. And Melanie, when we were talking about it, you said that your mission would be to follow and try and find water, correct? But can you tell me, what is this right here? It looks like a lady who's kind of bent over.
Well, usually when I watch TV, when they're searching for something, it's usually a detective searching, so I decided on that idea.
Excellent, excellent. And do you like watching for detective movies and things? Good. You might be the right one to send to look for water then. And Fabian, you told me that you would definitely take an American flag, which was why you had it on your patch right there. Why would you take a flag with you?
So I could mark it and say that I've been on the moon, so I can kind of show off.
Excellent. We're over here. We are all excited. We're going to keep doing activities. And right now, I do believe we have some more questions, so I'm going to go ahead and send it back over to Patricia at the Bank of Experts.
Great, thanks so much. We also have a winner from a crew patch competition that we've been doing online. So you'll probably be able to see that patch soon when it comes up on the screen. We also have another question.
Yes, this question is from Allison from Indiana. Okay, what's your question?
How did Mars get its name?
Oh, okay, experts, here's a tough one. How did Mars get its name? Tim? Okay.
Mars is the Roman god of war, and the Romans named it after the god of war just because of its color. It's the red color of Mars, as you see it in the sky, reminded them of blood.
Ah, excellent. Thanks.
Okay, the next question is from Ben from Missouri. Okay, Ben, what's your question?
Hi, we go to Mars. Will it just be Americans, or will it be international? Like, will we have Russians and who knows what?
That's a fantastic question. Actually, I'm going to try and send it over to our astronaut. The question was, when we go to Mars, are we going to have an all-American crew, or is it going to be an international crew? Rick, what do you think?
When we go to Mars, it will be, I'm positive, an international global effort. With the way things are working now, we're coming together. Our planet is getting smaller as we learn more about our technology. It's also going to be a very expensive. It's also going to be a very expensive effort, and we're going to need world cooperation and resources, education, and expertise from every country on the globe. So I'm sure it will be a global effort comprised of a global crew for the, as we say, the good of all mankind on the planet.
Okay, the next question is from Elizabeth from North Carolina. Okay, Elizabeth, what's your question?
Then why is Earth the only planet with an ozone layer? And what's the ozone layer made out of?
Okay, why is Earth the only planet with an ozone layer, and what is the ozone layer made of? Look at them. You might have stumped the experts. Well, Laura knows what ozone is, so let's go for that.
I believe ozone is 3 oxygen atoms instead of just 2. I'm not sure why Earth is only one. I think it has to do with the gravitational pull of the Earth, and only certain electrons can get out of the atmosphere. So I think they get trapped on Earth. So I think that's why we have an atmosphere.
Excellent. That was a great question. Thank you. All right, we have a question over here in the classroom now, so let's go there.
How big is Mars?
How big is Mars? John. I know you're busy answering emails, but how big is Mars?
Yes, well, the easy answer is Mars is about half the size of the Earth. We got that question earlier, so we got on the web real quick so I can give you a good number. The diameter of Mars is almost 4,000 miles across. Okay, so it's It's a good-sized planet, but compared to the Earth, it's a lot smaller.
Excellent. Thanks, John.
Okay, the next question is from Colton from Missouri. Okay, Colton, what's your question?
Have the rovers found any trace of life on Mars?
Okay, that's a great question. We're going to ask Dr. Eddie Tunstall that question. Eddie, have the rovers found any life on Mars?
Well, so far, the rovers have actually been exploring different parts of Mars, two different sides of the planet. And their instruments that they have cannot actually detect life per se, but they can indirectly detect life by detecting past signs of water. And at both sites, both Spirit and Opportunity have found signs of past activity of water activity on Mars.
Okay, the next question is from Kaylee from New York. Okay, what's your question?
How much time studying about Mars?
Can you please repeat your question?
Why do we spend so much time studying about Mars?
Oh, that is a good question, because we do. The question is, why do we spend so much time studying Mars? You think you have an idea?
Okay. I have an idea that maybe we're studying about Mars like a lot because it's similar to Earth in a lot of ways.
And we just want to explore. That's what humans like to do. So, you know, that's a fun thing to do as well. And we have another question.
Yes, the next question is from Trudy from North Carolina. From Oklahoma. Trudy from Oklahoma, what's your question?
How many rovers can be on Mars at the time?
Oh, okay. We're going to send that one over to Dr. Eddie Tunstall again. And that question is, how many rovers can be on Mars at the same time?
Well, currently we have 2 rovers on Mars at the same time. We also have 1 rover that was sent there in 1997 that's no longer operating. We can actually design a particular mission that can send many rovers at once. We haven't done that yet, and we don't have a reason to as yet. But we can send as many rovers as possible, as long as the communications capability allows us to talk to those rovers from Earth.
Excellent. All right, we're going to head back over to Eddie and to Amy, and they're going to talk to us a little bit about some rovers.
Okay, I'm here with Dr. Eddie Tunstall, and he's from the Jet Propulsion Laboratory, and he works with the Spirit and Opportunity rovers. So why don't you tell us a little bit about those rovers and their mission?
Sure. The Spirit and Opportunity rovers were designed to be robotic field geologists. What that means is that they have to explore the surface of Mars, looking for past evidence of water activity at the different sites where they landed. Spirit landed at a place called Gusev Crater, and Opportunity landed at a place called Meridiani Planum. These are 2 different sites on opposite sides of the planet Mars. And they're currently there exploring the geology and the past climate of Mars using their scientific instruments.
Very good. Now, where are Spirit and Opportunity right now, and how long are they going to be alive, and what are we learning from Spirit in the Columbia Hills region?
Currently, Spirit has traveled about 2 miles away from its landing site, where it landed in January of 2004. And Opportunity has traveled about 1 mile from its landing site. Spirit is up in the hills that we call Columbia Hills right now. And it's climbed those hills because those hills are very ancient hills that we believe will have signs of ancient water activity. And we spent much of the mission actually trying to travel to those hills. Right now we're up in the hills and climbing them. As we speak today, Spirit is climbing further into those hills right now. Opportunity is in a large crater that we call Endurance Crater. It's about the size of a football stadium. And it's currently exploring additional signs of water activity at that particular site.
Now, how much longer do you think they're going to live? Because they're like 3 times past their normal lifespan right now, aren't they?
You're exactly right. And for that very reason, it's very hard for us to actually predict when they're going to stop operating. And so we'll continue to operate the rovers until they actually, at least one of them is still operating. We'll continue to do it. So far, so good, and we'll see how long it lasts.
Okay. And we have a question now. Brian from California. Can you go ahead with your question?
How do the rovers work?
How do the rovers work? Maybe you can talk about how the wheels move.
That's a good question. Each rover has 6 wheels, and it's able to drive forward, backward, and it can steer in place, as well as make nice arcing turns around the terrain. The rovers also have computer software that allows and cameras that allow them to look at the terrain, figure out whether or not there are obstacles that they can't travel over, and figure out how to travel around those obstacles. The way that they work is that we send commands to them every day, a full day's worth of commands, and tell them where to go and what science to do. And when we send those commands, they actually execute the commands all alone and by themselves, and only communicate with us at the end of the day.
That's a good question. Okay. And I think now we're going to go over and see some rovers actually move over at our Mars yard. Robert?
Hi there. I'm Robert Stevens. I'm founder and chief inspector of the Geek Squad. I'm joined here today by my esteemed colleague, Double Agent Jason Lambert here in Houston. And we've got 2 rover teams with us today. These kids have been working all week on these rovers that they made themselves and designed themselves. So quick, let's go through the introductions. We'll start with you.
I'm Scout Creason. I'm from Galveston, Texas. I'm 10 years old and I'm in 5th grade.
And we'll pass it on to Travis.
I'm Travis Stamp. I'm from Muncie, Indiana. I go to Burst Lab School and I'm in 7th grade.
Hi, my name is Marjorie Frone and I go to school at St. Edward Catholic School in Spring, Texas. I'm in 6th grade and I'm 11 years old.
I'm Andrew McGilvery. I'm 9 years old. I'm in 4th grade and I go to Lake Harriet Community School.
Andrew, where's that school located?
In Minnesota.
That's right. Okay, now, before we start the rover missions, we have 3 missions today. These missions have all been kept secret from you all week. So you had to build your rovers without knowing what they were going to have to do. And kids all over the country voted online on which missions they wanted to do. Now, before we get to the first mission, we're going to show a quick video on how they calculate the poles. Let's see that. Okay, before we go to the video, we want to talk about how you built your rovers. Now, I don't know, I still play with my Legos, but tell me, what was it like putting these together? Andrew, what did you learn this week putting your rover together?
We learned that if you don't, if you press both of the wheels forwards and one goes, 2 wheels go in towards each other, you're not going to move forwards. And that's about it.
Okay, well, it looks like we got the poll results just came in this last second. Let's check out the video on how the poll results are calculated. Okay, so the results are in. Are you ready for your first mission?
Yeah.
Okay, Agent Lambert, let's have the first mission. All right, why don't you take your places over here at the controls of the rover, and I'll read you mission number 1, Search for Life. Your mission is to collect and return a sample showing the former presence of life. Your scientists require a sample that is a minimum of 2 inches by 2 inches, and we've got 2 2-inch samples here, so each rover, you have to maneuver over here, pick up this white sample, and return it to base at the edge of the Mars yard. You ready? Let's get to it.
What's that one right there?
Okay, while they're going on their first mission, we're going to pass it back over to Patricia for a question. Patricia?
Okay, this question is from Caitlin from Arizona. Okay, what's your question?
How long does it take for our shuttle to get to Mars?
How long does it take to get to Mars? Actually, we don't send shuttles to Mars, but it does take quite a while. Ed, can you help us with that?
Sure. It took Spirit and Opportunity spacecraft 7 months to travel through space from Earth to Mars.
And what kind of a vehicle were they in?
They were enclosed inside a lander that had an attachment called a cruise stage, which is basically the engine that flies it through space. So it was a pretty small spacecraft, just big enough to actually carry the lander and the rover inside.
Excellent, thanks.
Okay, the next question is from Alessandro from North Carolina. Okay, what's your question?
Yeah.
Go ahead.
Oh,
Yep.
how long does it take to build a spaceship?
How long does it take to build a spaceship? Tim, can we come to you for that one?
I would say Yeah, I'm not a shuttle engineer, but I would say that if you started now, it would take a few years to build a new space shuttle. So what NASA is really planning to do is to stop flying the space shuttles entirely in a few years so that we'll have newer, better spacecraft for our astronauts.
And you're working on the propulsion system for new spacecraft. And how long have you been doing that?
I've been doing that for 8 years, but the engine we're working on is only to go between planets. We will also need a new vehicle to get us up from the surface into low Earth orbit.
Okay, so it takes a while to build these spacecrafts.
Okay, we have another question from Katiana from Minnesota. Okay, what's your question?
How long does it take the command to get an opportunity?
Can you please repeat your question?
Just a little bit louder for us.
How long does it take the command to get an opportunity?
How long does it take for the commands to reach Spirit and Opportunity? Any idea?
I'm not quite sure.
No? No guesses on that one? Eddie, how long does it take for those commands to go?
Well, it depends on what time of the year it is and how far away Mars is from Earth, as they keep changing while they're orbiting around the sun. But at the beginning of the Spirit and Opportunity mission, it took about 9 minutes for commands to get from Earth to Mars. Now or later, when Mars is furthest away, it can take about almost 15 or 20 minutes.
Oh, so quite a while.
Okay, we have another question from Taylor from Oklahoma. Okay, what's your question?
Has there ever been a shuttle on Mars, and what would it be if there had?
Okay, has there ever been a shuttle on Mars? And if there was, what was it like? But do you have any guess on that one? Do you think the shuttles go to Mars?
No, we haven't sent any shuttles to Mars yet. We only have rovers.
Right, actually. And so the shuttle is made to be in low Earth orbit, so it's made to stick fairly close to Earth. All right, we're going to head off to our next video on how do we get to Mars.
Whoa, that mission segment went exactly as planned. We couldn't ask for a better crew on this one. How's everyone holding up?
We've had the flight surgeon monitoring their situation closely since the start of the show. Everyone appears to be in good shape.
This gauge shows an increased heart rate for Patricia. Is that reading correct?
She's been getting some tough questions today, so the reading is accurate, but she's been training for months, so I'm confident she'll pull through just fine.
Okay, but let's keep an eye on that for the rest of the mission. She needs to be at full strength for the end of the show.
Check, I'll keep an eye on it.
Okay, everyone is in good shape. Let's get the next mission segment started.
Okay, all sensors read clear and activate. How will we get to Mars?
Excellent. Let's see how they handle this one. All right, so if we're going to figure out how do we get to Mars, we really have to understand a little bit more about how long it's going to take us to get there, meaning how far away it is. So you guys at home and in the classrooms can do the same activity that we're about to do if you have the right kind of fruit. Now I have a cantaloupe in my hand, and I'm going to say for our activity today, this represents the size of the planet Earth. Now Molly, what are you holding?
I have a lemon, and it represents the moon.
Awesome, so you guys can see at home that the Earth is a lot bigger than the moon, right?
Yeah.
Okay, now what are you holding, Colin?
I'm holding an orange, and it represents Mars.
Okay, good. So now that in this activity we've kind of identified the difference in size of the Earth, the Moon, and Mars, let's talk about distance. So Molly, if this is the Earth and that's the Moon, how far away do you think you would have to walk from me to show the distance between these two objects?
15 feet.
About 15 feet? Okay, so take off that direction. Bye, Molly. Okay, now as Molly's walking away 15 feet, Colin, let's talk about the distance from the Earth to Mars. How far do you think you'd have to walk?
Well, I know a long way, but I'm not quite sure.
Okay, you're not quite sure.
No.
Well, you know what? I know that Travis is on standby, and he's actually going to show us how far away Mars is from my cantaloupe. Take it away, Travis.
Run, Travis, run!
Enough 2.5 miles. Wow, you only had to go 15 feet. Well, that gives us a little bit better idea of just how far away Mars is from Earth. Now, when you consider that distance, you have to think about how long it's going to take us to get there. Now, Colin, have you learned anything about that? How long will it take with current technology to get from the Earth to Mars?
With current technology, it should take about 6 to 8 months.
6 to 8 months?
Yeah.
Wow, that sounds like a long time to be on a road trip.
Yeah.
Wow, okay. Well, Molly, if we're going to take all that time and energy to get there, how long do you think we should stay?
About 2 years.
About 2 years. So we're looking at about 8 months to get there. 2 years on the surface and 8 months home. Wow, that's like 3 years and 4 months. A long time to be away from your friends and your family, right?
Yeah.
Now, would either of you want to go on a trip like that?
Maybe.
Maybe? Colin?
I might if I can take some things and have the right training.
Definitely, you want to take some things with you. I know I certainly would want to go. Now, I understand that we have a caller, Juan from Colorado. Go ahead with your question.
Hi, guys, Juan. Hello?
Hi, Juan. Go ahead with your question.
I would like to know how many degrees in Fahrenheit a average spacesuit can take outside of the space shuttle.
Outside of the space shuttle, how many degrees of Fahrenheit can the spacesuit take? Was that your question?
Yes.
That's an awesome question, and actually in space, you wouldn't believe how extreme the temperatures are. They range from minus 250 degrees Fahrenheit to plus 250 degrees Fahrenheit. So those are the temperature extremes that we have our materials ready to take on the spacesuit. All right, I know we have another question. Ashlyn from Indiana, go ahead.
How old is Mars, and could it be the same age as Earth?
How old is Mars, and can it be the same age as Earth? What do you guys think?
Yeah.
Yeah? You think it's about the same age?
Yeah.
You think that Mars and Earth were probably created at about the same time?
Probably, yes.
All right, good. I think the same thing. In fact, you know, there's a lot of theories out there about how the solar system was actually created. So it's very likely that the Mars and Earth were created about the same time, and that's an excellent question. All right, guys, we have another question. Jacqueline from North Carolina. Go ahead, Jacqueline.
If we are going to Mars in our generation, what new technology will we get to enjoy?
Oh, I like this question. If we were going to Mars and needed new technology, what kinds of new technology would we get to enjoy? So let's think about this, because this is something that still needs to be answered, and it's probably going to be their generation and yours that are going to determine this kind of thing. So what would you like to bring, Colin? What kinds of new technology would you like on your Mars mission?
Well, you mean stuff that I'd like to bring personally?
Sure. What could we improve upon for our Mars mission?
Well, we can improve on different types of engines, maybe, and mainly just getting us there faster.
Good, and that's a pretty big issue, because I don't know if I want to hang out with my friends and buddies for 6 to 8 months, the same crew in the same vehicle. Good, I understand we have another caller. Stephanie from New York. Go ahead, Stephanie.
When the space shuttles retire, what will replace them?
Oh, that's a great question. When the space shuttles retire, what will replace them? NASA is actually working right now on the next vehicle, which is called the Crew Exploration Vehicle. Now, the space shuttle, we're going to try and retire it about 2010. So by that point, what we call the CEV, or Crew Exploration Vehicle, should be up and running. Awesome questions, guys. Thanks so much, and keep on calling in and getting on the website. All right, so Colin, you mentioned that you might want to have some new engines to help us to get to Mars faster. So you said 8 months out with current technology. What have you learned about some of the technology that NASA is working on right now?
Well, NASA's working on a new engine called the Vasimir engine, and it takes plasma and puts a magnetic field around it, and so it's about an inch diameter, and all of that running through the magnetic field creates a power source.
So that sounds like a pretty cool engine, maybe a more efficient use of fuel and energy to get us there a little bit faster. Now, you guys actually toured the Advanced Space Propulsion Laboratory, right? All right, I understand we actually have an expert on our panel, Dr. Tim Glover, who's available to take your questions if you want to know a little bit more about the Vasimir engine. Also, get online and ask him through the internet. But we also have a video to show you guys so that you can kind of feel like you went and toured the laboratory as well. So check this video out.
What we're trying to do here is build a new kind of rocket engine that would go from the Earth up to other planets a lot faster than we can do it now. So what you're looking at here is a vehicle that could go to Mars in about 90 days rather than like 6 to 8 months, which is what it would take with chemical propulsion. Inside the space shuttle engine, you basically have a metal tank that's open at one end. You spray in hydrogen and oxygen, and you burn it. And so you can burn it at a hot enough temperature, at a certain temperature, but you can't burn it any hotter because the walls of your combustion chamber would melt. We don't hold our propellant with metal walls. We hold it with a magnetic field, so that means we can heat it up to any temperature we want. Millions of degrees. Even though it's a low amount of thrust or push on the vehicle, it can pick up a lot of speed over time, and it can use a lot less propellant to do it.
All right, well, that looked like it was a really fun experience. Did you guys enjoy that tour?
Yeah.
Good. Did you learn a lot?
Yeah.
All right, so it looks like NASA's really working hard to get us to Mars a lot faster. Okay, now, if you guys are in the classroom or at home, we're getting ready to do our lofting activity with the kids in the classroom here at Space Center Houston. And we're fortunate enough to have an awesome person who's an expert on this, Molly to my right. Now, Molly, can you explain the objectives of the lofting activity?
You have a string from the ceiling to the floor, and you have a flag about midway. And you're trying to get your space shuttle to the flag.
Okay, so it sounds like kind of a tough challenge. Now, do you have any pointers or key ideas for the designs of the students in the classroom?
Well, when we were doing this activity, we discovered that it's easier to use a lot less tape because it doesn't weigh it down as much.
Okay, so do you think that's a pretty key point there, to not weigh down your balloon too much?
Yeah.
Okay, that's actually true of all lifting designs. When we're creating our designs for space vehicles, we want to keep the weight down so that we don't have to concentrate on having that much fuel or propulsion to get it up off of the planet, right?
Yeah.
Okay, any other hints you can give the students?
The simpler the design, the better.
All right, I think those are two good points. Hopefully those of you who are doing the lofting activity will take that into mind, keep the weight down, and keep your designs nice and simple. Now, I understand we have another question. Kirsten? Go ahead, Kirsten.
Mars climate to change so drastically?
Can you repeat that question for me, please?
What causes Mars climate to change so drastically?
What causes the Mars climate to change so drastically? You guys know the answer to that one? I think it's kind of like Earth. You know how we have the changing of the seasons here on Earth, right? And so sometimes we're a little closer to the sun, sometimes we're a little further away, sometimes it's hot, sometimes it's cold. Well, Mars has an environment. It has an atmosphere just like Earth does, except it's made up of 95% CO2. So we can actually breathe on Mars without the aid of a spacesuit, which we'll talk about that in a few minutes. So just like the Earth has the changing of the seasons, so does Mars. And that's why you see that crazy temperature extreme on Mars. All right, good question. Now we're going to go back to Patricia and Kate. So if you guys have some more questions, go ahead and call it in. Thanks so much.
Thanks, Heather. We do have another question.
Corbin from Indiana. Okay, you can go ahead and ask your question.
How fast does Mars rotate?
How fast does Mars rotate? Who am I going to pick on for that one? John, okay.
It's pretty similar to Earth, where we have a 24-hour day here on the Earth. Mars spends about 24 hours and 39 minutes. So it's a little bit longer than the Earth. And actually, the scientists and engineers who are working on the Mars missions have Mars clocks so they can be on Mars time versus Earth time.
Ah, very cool. Very cool. We are going to now head over to our Mars yard and check in on our second mission. So over to you, Robert.
Thanks, Patricia. Okay, well, the first mission turned out pretty well. You both accomplished bringing your sample over from this end of the Mars yard to there. And now we're going to do our second mission. Let's go ahead and open her up, Agent Lambert. Now, these are the second mission voted on by kids all over the country. Mission number 2, landscape survey. This one's my favorite. Your mission is to visit a crater, a blueberry site, a fossil site, and the top right perimeter in that order. Also, you must pause and shine your camera on each item, then return to the landing site within 3 minutes. And I'm going to add one little thing to this. Now, we've used real blueberries for the term that they use on Mars. I want you to pick up your blueberries and bring them back to base without crushing it or making any blueberry jelly. Got it? Okay. Good luck. Okay, and while they're starting that off, we'll hand it back over to Patricia for questions.
Great, thanks. We also have a lot of folks who are emailing in questions, so good job, keep that going. And we have one from?
Okay, we have a question from Rachel from Indiana. Okay, Rachel, what's your question?
Are the seasons on Mars the same as the seasons on Earth?
Good question. The seasons on Mars the same as the seasons on Earth? What do you think, Rick?
All right.
You think that one's for John?
Very different.
Well, there are seasons on Mars, just like on the Earth, because the axis of rotation is tilted, so you have winter, summer, spring, and fall. But since Mars is further out from the sun, it takes longer to get around the sun, and Mars's orbit is more elliptical than the sun, so sometimes you're further out, sometimes you're closer. The seasons can vary. In the southern hemisphere, you have very, very long, cold winters. In the northern hemisphere, you have very short, but also cold winters. So yes, there are seasons on Mars, just like here on the Earth.
Very neat. Okay, the next question is from Brant from Indiana. Okay, Brant, what's your question? Go ahead, you can ask the question now.
Well, it looks like we've lost him. Let's check in with David from Arizona. David, are you with us?
Yeah, how much fuel does a spaceship have, and what would happen if you ran out?
How much fuel does the space shuttle have, and what would happen if you ran out?
Well,
You have one? Yeah.
if you running out of fuel in the space shuttle would be a very bad thing, because what happens is the three main engines in the back of the space shuttle and the solid rocket boosters are what power it when it goes up into space. Now the solid rocket boosters are big Roman candles, and they just burn until they go out. And then we have liquid hydrogen and liquid oxygen in the main tank, and that powers us for about 8 minutes or so up into the lower parts of the atmosphere. And then the engine shut down, and we have to make sure that the engine shut down nominally, which means in a normal fashion, and that means we need enough fuel to power the engines and the cooling and the turbo pumps. If we were to run out of fuel sooner than we needed, we could have destruction of the engines, which would be a very bad thing.
Yeah, very bad.
Okay, the next question is from Justin from Wisconsin. Okay, what's your question?
You walk on Mars like on Earth, and is there any gravity?
Is there any gravity on Mars like there is on Earth? And can you walk on Mars like you can on Earth? That's a great question. Who wants to take a gravity question? Yeah, about a third of it, right? John, give us the actuals.
Yeah, we talked about Mars being about half the size of the Earth, but it's actually less dense than the Earth, so the gravity on Mars is only about 38%. So if you were to weigh 100 pounds here on the Earth, you go to Mars, you're going to feel like you only weigh 38 pounds, so it's kind of like an instant diet.
So you still could walk, though, on Mars. It would just be a little different?
Oh, yeah. Actually, Mars's gravity is very comfortable. We have a plane here called the KC-135 that flies big parabolas in the sky, and we can simulate Mars's gravity. I've done that before, and it's a real comfortable environment to work in.
Very neat. Okay, now we have a question from Tyler from Indiana. Okay, Tyler, what's your question?
What is the mass and weight of Mars?
What is the mass and weight of Mars?
Wow. You guys are just trying to stump us. What is the mass and weight of Mars?
Mass is about 1/10 that of the Earth.
Say that again?
The mass of Mars is about 1/10 that of the Earth.
About 1/10 of that of the Earth. Great questions, everybody. Keep them coming in. And remember, you can do them online as well as phone in. Right now, we're going to toss to our next video, and it's How Do We Live on Mars? Have a look.
We came out of that segment pretty hot. What are the gauges showing?
Nothing we have to worry about. We've been seeing high readings of phone calls today, but nothing our systems can't handle.
Great. How about the panel of experts? How are they holding up?
The volume of data being processed in the panel is record-breaking. We've never seen any readings like this. This stuff you just can't train for.
Well, they're handling these questions with no problem. Let's keep them going until the end of the show.
Okay, I'll prepare them for an increase in data flow.
Excellent. Now let's set up our final mission sequence.
Okay, host in place. I've activated the elements for the final mission segment. On your count.
Okay. In 5, 4, 3, 2, 1. Engage. How will we live on Mars?
How will we live on Mars? The final mission of our segment. Engage. Let's bring her home.
Hi there. Well, we are having a great time here, aren't we?
Yeah.
This has been a lot of fun. We're going to have even more fun, and hopefully you'll be having so much fun back in your classroom. You're going to want to call and ask us questions because we really know a lot of answers to stuff. Okay, to start off with, we're just going to review what we've talked about already. We've talked about what it's going to take to get to Mars and how we're going to get there. Now we're going to talk about what happens to the body. My name is Dr. Rick Schuring. I'm an aerospace medicine doctor. Here we go again. I'm going to take a microphone here. Actually, now I have two. And we're going to talk about what happens to the body on Mars, because some really neat things happen. And that's something that both Colin and my friend Marjorie here we've been talking about. We're going to do some really cool experiments too. So, Colin, what are some things you've learned about what happens to the body when we go to Mars?
Well, there are a lot of different things, like with bones, they lose density, and muscles, you don't really use them as much, and psychologically you can't see home, so some astronauts struggle with that.
That's right, and that could be a big problem. And Marjorie, what have you learned?
Well, in space there's no gravity, so all your blood rushes to your head.
That's right, and we're going to do some neat things to show what that would be like. My friend Colin will show us because he likes to do that. Anyway, well, first thing we're going to do is talk about how doctors actually study the effects of what happens to the body when we go into space. And Colin, can you think of any things that we would do here on Earth that would kind of help us learn what happens when we go to space?
Well, they do some testings, like in Devon Island, which is in
the Arctic Circle.
Yeah, the Arctic Circle. And that kind of simulates what it's like on Mars, because it's very isolated and remote, so you kind of feel like you're away from home, and they stay there for a while, so they can sort of see what the psychological effects are.
That's right, and we'll actually show a picture of what Devon Island looks like. It's way up towards the North Pole, and it's a lot like the environment of Mars. It's very cold, and there's not a lot of people around. You can't stop off at a gas station or anything like that to get directions, so you're going to be up there for a long time, and it kind of teaches us what we're going to experience when we go to Mars. What are some other things that we can learn from these different analog or similar environments, Marjorie?
Well, we can learn that how to build rovers.
Yeah, you can do that too.
So.
But we can also learn, if you've got a medical problem, what kind of things we need to do to prevent these problems along the way. Okay, well, the first thing we're going to talk about is the musculoskeletal system, your bones, and actually what happens. And that's one of the most common problems that astronauts have. And the first one is actually called low back pain. And we're going to show a picture of actually what a low back looks like. And when you get into space, we talked about what happens when there's no gravity around. What do you think happens to your spine or your back when you get into space, Colin?
Well, since there is no gravity, it expands, because on Earth normally gravity is compacting your spine, but in space there is none of that, so...
Right. Yeah, your back's kind of squinched down because of gravity, but as soon as you get into space, your spine actually elongates almost 1 to 2 inches. So if you could imagine you're getting 1 or 2 inches taller, that'd be pretty cool for people who are short like me, right? Okay, the next thing that we're going to talk about is a big problem, and that is bone loss. Now, an earlier caller had talked about how people will benefit from the things, the technologies we learn in space, and medical things is one thing, because a lot of people have bone loss problems. When you go into space, because you don't have gravity, your bones can actually get kind of weak. And there's something similar to what we're going to show here in this picture. This picture shows normal bone on the left side, and on the right side shows bone that has gotten kind of weak and it's lost its calcium over the years. Okay, well, the same thing can happen to astronauts, but in a lot faster time. So the aerospace medicine doctors have to figure out how to keep the astronaut bones strong. And here's a good example of normal bone. And Colin, you hold on to that. That's a piece of chalk. And how would you describe that?
Well, it's hard and it feels pretty sturdy, and not extremely brittle.
Okay, right. So it's pretty strong. It's pretty dense. Now I'm going to give a malted milk ball that I've cut in half here for Marjorie. And how would you describe that?
I would describe it as porous and light.
Right, and it's not quite as strong as a piece of chalk, and that may be what the bone is actually like if you've been in space for quite a long time. So we actually have to prevent that from happening, along with muscle loss. Your muscles get weak, and the way we do that is through exercise. One of the ways we do it. And actually we can have the astronauts lift weights in space, but there's a problem with weightlifting in space. And what do you think that is, Colin?
Well, in space you're in a weightless environment, so lifting weights wouldn't have any effect on your muscles.
Exactly. So the way we do it is we actually have a special device that the astronauts can use that it actually creates resistance, and they can actually lift weights to make their bones stronger and their muscles stronger. But we'll probably have to use medications also to do that. The next thing we're going to go on and talk about is actually the neurovestibular system. And the neurovestibular system, after these pictures here of astronauts exercising, is your balance centers. And your balance centers actually control where you're at in space. If you close your eyes, you know on Earth where's up and down and where's right and left, because your inner ear, your brain can kind of tell you that. Well, that changes in space, and that can cause all kinds of problems. There's a picture here on the monitor about your semicircular canals. And those are special centers in your inner ear that actually tell you where you're at in space. Now we're going to do a little experiment to show how you can actually mess that up by having Marjorie spin in the chair. And you can do this exercise also in your classrooms. And it's going to be kind of neat because we're going to have Marjorie spin around one way with her eyes closed. And as I slow her down, I'm going to ask her to tell me which direction she's going. And it's going to change, and we're going to kind of trick her. And the same kind of thing can happen in space. So everyone gets their chairs together, and we're going to start spinning around, but not too fast. We don't want to get too crazy and dizzy, okay? You ready? Okay, so she's going to point with her thumbs which direction she thinks she's going. Okay, ready? Now, all this time, there's a little device inside your inner ear and those semicircular canals that are kind of like marbles on hair cells, and they float in fluid. And when that fluid and those hair cells change, it tells you which direction you're going. But after a while, your brain stops sending the signal of which way you're going. So Marjorie feels like she's going right now because that fluid and those marbles in your inner ear are kind of shifting that way. But in a while, they'll stop doing that. And we'll see what happens when we slow her down and stop. And if you're doing this in your classroom too, this is kind of fun. But again, don't spin too fast because you might get sick to your stomach. How you doing, Marjorie? Okay. Okay, now we're going to start slowing her down. And keep pointing and tell me which direction you feel like you're turning. Okay, which direction are you turning? Okay, now open your eyes. You've actually stopped. That's kind of a real subtle way to show how your inner ear, your semicircular canals, and your balance centers can actually mess you up. You gonna be okay? Okay. Now Marjorie kind of has a look on her face that astronauts might kind of look like when they're in space the first couple of days, and that's called space motion sickness. They get really kind of sick and disoriented the first couple of days because they don't have gravity to push down and tell them what's up and down, right and left. So one of those problems the flight surgeon has to deal with to try to prevent them from getting sick. Okay, well, the next thing we're going to go on and talk about really quick is the psychological problems, the problems that happen when you've been in space and away from your family for a long time. Imagine taking a long trip with your family, but your family's not with you. So you're just kind of traveling out there on your own. What would you feel like, or what do you think you would experience if you're out there without your family, your friends, or anyone else?
Well, I'd get really lonely.
Okay.
And I'd want to be reminded of home.
Okay. And what do you think you would bring to kind of make you feel like you're at home?
Family mementos, definitely, like a picture of my family and a reminder.
Okay, well, those are similar things that we actually try to do with the astronauts. We have them take care packages to actually take up music, take up musical instruments, to do things that make them feel like they're back at Earth, just to kind of keep them company. They'll have their crew members, but there's things on Earth that are kind of unique to Earth, so those are some things that we really want to be able to do. So it looks like we've kind of answered some of our questions here, and certainly if you have any questions, definitely give us a call, and we'd love to answer them. We're going to go back to Patricia now, and thanks a lot, Colin and Marjorie.
Yeah.
Great, thanks so much. What we're going to do is we're going to pop over and see how our mission is doing. We have our third mission for our students, so let's go check on those folks and then come back for some questions.
Thanks, Patricia. Well, second mission was accomplished pretty good. One of the rovers, as you can see, in its little claw there, has one of the blueberries, and it's not even smashed. So pretty good job there. Well, now we're ready for our final rover mission. Let's open her up and find out. And mission number 3 is Race of the Red Planet. Your mission is to race the Mars rovers around the perimeter of the Mars yard to determine the appropriateness of the vehicle components in this environment. So it looks like we're going to have a rover race. You two ready? On your mark, get set, go. And while they're starting out, we'll take it back to Patricia for a question.
Great, thanks so much, Robert. I'm going to go to Tim, and Tim, you had a great question online. The question was, and this is a tricky one, everyone, is there gravity in space? Now, that's a tricky question.
Okay. The answer is that there's gravity everywhere. And for example, the astronauts, when they're on the space shuttle in orbit around the Earth, there's definitely a force of gravity on them, but they're moving with it. Right now, what you feel as you're standing on the floor is the force of gravity pulling you down, and what you actually feel is the force of the floor pushing back up on you, called your apparent weight. When you're in orbit, there is nothing for you to be resting against, and so you don't have apparent weight, and that is what we call weightlessness.
Okay, great. So there is gravity out there in space, but the astronauts are in a weightless condition. Excellent, excellent question. And now I think we have some callers calling in. Who's our first person?
Okay, our first person is Anna from North Carolina. Okay, what's your question?
Can you explain the differences between the different rocket propellers?
Can we explain the differences between the different rocket propellers?
Oh, okay.
That would be Tim.
The main difference is in how fast the fuel comes out the rocket engine itself. The space shuttle main engines throw their exhaust out 4 kilometers a second, and the rockets that we're trying to build with Vasimer would kick it out about 100 times faster.
Wow, so really fast. Excellent. All right, we have another question.
Okay, it's from Taylor from North Carolina. Okay, what's your question?
Mars ever break apart? If it can, what caused it to break apart?
Can you repeat that again? There's some loud noises in the background there. Try again. Oh, can Mars ever break apart? Well, which one of you wants to answer that question? Dr. Eddie, can Mars ever break apart?
That's a very interesting question. I don't know the actual answer. I can think of scenarios where maybe a very large asteroid might impact the planet and cause it pieces to break off, or perhaps for it to break apart, but I'm not sure about that.
Okay, that's a great question.
Okay, the next question is from Joey from New York. Okay, Joey, what's your question? Okay, you can ask your question now.
Yes. How long have we been studying Mars and sending rovers up?
Okay, that's kind of a history question. How long have we been studying Mars and sending rovers up to Mars? I'm going to come over here.
Let's see. We've been studying Mars for a very long time, dating back to ancient history, when we just looked with our naked eye, and then eventually with telescopes. In modern times now, we have only sent rovers up to Mars ever since 1997. There was some activity in the 1970s where we sent landers to Mars, and the Russians also actually sent a roving vehicle to Mars, but it didn't meet with great success.
Excellent questions.
Okay, our next question is from Austin from Indiana. Okay, what's your question?
If we could start civilization on Mars, why or why not?
Wow. Could we start civilization on Mars? Why or why not? John, do you want to try that one? Maybe both you and Laura.
Sure, we could always start a civilization on Mars, but it's going to take, of course, a great willpower to do that, because it's going to require lots of materials and a good commitment of time, you know, over many presidents, over many Congresses. So the willpower has to be there, number one. But I think humans can pretty much do whatever we want, and we just put our minds to it.
Right. Laura, anything to add to that? Sounds good. Sounds great. Okay.
Okay, our next question is from Caitlin from Arizona. Okay, you can go ahead and ask your question.
Why is Mars so red?
Why is Mars so red? The red dust on Mars. Why is Mars so red?
Well, I think we had that question a little bit earlier, and as I recall, we had a very good answer from over here.
Who's taking that one? Why is Mars red?
Well, you look at Mars, it's not actually red. Even though we call it the red planet, it's more orange than it is red. And that's mainly just because most of the iron, or a lot of the iron on planet Mars, has oxidized or it has rusted. And if you look at the chain on your bicycle, or other things here on the Earth that have rusted, they kind of get that orangey look to them. And so it's a pretty simple answer, really.
Okay, great.
Okay, our last question is from David from Missouri. Okay, what's your question?
I was wondering approximately how many years would it take to start a colony on the moon or even Mars?
Okay, another excellent question. How many years would it take to start a colony on the moon or on Mars? Anybody want to venture a guess on that one? Okay, Tim's going to venture a guess.
It only takes 3 or 4 days to get to the moon, so as soon as you can build the components of the space station, space base, if you want to call it that, for the moon, you can have them there in a few days. So that would be the shortest time.
Okay. And we're going to head over to Amy, who is with a spacesuit, and you can learn how, if you're going to be colonizing on the planet Mars or on the moon, what you're going to need when you're there. So, Amy.
Thank you, Patricia. Yeah, when we go to Mars, we're going there to explore, so we don't want just to sit inside, we want to go outside. And when you go outside, you need to wear your spacesuit. Colin, what are some things that you'd like to know about the spacesuit that we have with us today?
Well, one of my questions is, how flexible are the spacesuits?
Well, let me ask Rick to answer that question, since he's worn the a spacesuit in space?
Okay, flexibility is an issue sometimes in the spacesuit because you can't move as well as you would in a normal situation like we are right now as you can when you're in the suit. The legs are stiffer. The arms are actually pretty mobile, and your shoulders are on bearings. So your movement is a little bit different. So there are some things you can do fairly normally in a suit, and other things like bending your knees or trying to move your legs outward from your body that almost is impossible. And so you have to plan your work around how the suit reacts in you. In other words, you work with the suit, you don't fight the suit when you work.
And one of the things that I do here is I work on developing the new spacesuits that'll go to Mars. And so we're trying to fix a lot of those things because when you go to Mars, you're going to have to do a lot of things like a geologist would do. So they're going to walk up steep slopes, walk over rocks, bend down to pick up rocks. And so we have to make the spacesuit so that it'll allow you to go and do those things. We need to build a lot more mobility into the waist and the hips area as well as building boots that you would wear to hike in the mountains. These are definitely not what you would want to wear to go hiking in. These are more like clown shoes right now. Okay, Colin, do you have another question?
Well, how do you out on spacewalks? How does the life support system work?
Okay, that's a good question too. Basically, the spacesuit is a people-shaped space vehicle, so it has to do everything that a space vehicle does for you. So in the life support system here, we have an oxygen supply for you to breathe and to keep your spacesuit pressurized so you stay alive. We have a battery system or some kind of power system so you can have power to control the computers and the electronics in the spacesuit, as well as a communication system so you can talk to your buddy while you're out doing EVA and talk to the habitat also. So that all allows you to go and do what you need to do on the surface, as well as here's your propulsion system so you can get around. Okay?
What kind of materials do they use to protect from Mars, like dust storms or radiation?
Oh, that's a really good question too, because those are two major differences that we have from this spacesuit, which is used in the low Earth orbit environment. This is a shuttle spacesuit, to a spacesuit that we use on Mars. Because on Mars we do have dust, which we don't have in low Earth orbit, not a lot of anyway. And so we're going to have to make materials that keep the dust out of the spacesuit, because the spacesuit has bearings for some of that mobility. So the bearings let you rotate parts of the spacesuit, and dust and bearings don't get along very well, so we're going to have to come up with materials that will protect the spacesuit from the dust. These are the layers that we have in the spacesuit right now, and these protect the spacesuit from getting torn and ripped, and also the extremes of temperature in space, and micrometeorites and orbital debris, the little bitty space rocks and space junk. Well, we have to add layers or come up with new materials that can protect it against the dust and also radiation. Like Dr. Rick was talking about, radiation's a problem in space. We're going to have to build radiation protection into the spacesuit. We don't know how to do that yet, so it's a challenge for the future. Okay? Okay, and now, after you're done working a full long day on the surface, you're going to want to go back and relax at home. So let's talk to Heather about habitats on Mars.
Thanks, Amy. You're absolutely right. Now that we figured out how we're getting there and how we're going to live there, we have to figure out exactly where we're going to live on Mars. So, Molly, why do you think we need a habitat in the first place?
To protect us from Mars's sandstorms and the temperature, and just to have a house.
Okay, good points. I mean, we really need a lot of protection from the Mars environment. Good. Now, some of you at home and in the classrooms have probably thought about a habitat, or maybe you're designing some right now. Now, what I'm sitting next to are the designs that our students put together. Ari, why don't you show me a couple of things that you guys put in your habitat?
A kitchen, a social room, and a laboratory.
Good. Now, why did you put a laboratory in your habitat, Ari?
So if you find any, interesting rocks, you can study them.
Good, good. I think we'll probably be finding a lot of rocks on the surface of Mars, right? And since you're going to be there for 2 years, maybe even longer, you might want to consider doing the science on the surface in your habitat, right? Good point, Ari. Okay, Molly, what's in your habitat?
We have a bedroom so you can relax, well, tons, but anyway. An exercise room to stay healthy, and a greenhouse.
That's good. Now I'm interested, why did you put a greenhouse in your habitat?
We put a greenhouse so that you can grow your food, because by the time you get to Mars, your food probably isn't going to be that good.
Okay, good. And we all know that we all like to eat, so we want to have lots of fresh fruits and vegetables on hand that we can grow in our habitat. Good points. Now, these are the kinds of things that NASA is thinking about right now in terms of habitat design. And in fact, we have a great video. It's the best video of the entire show, really, all about the Advanced Integration Matrix, a project that we're working on at the Johnson Space Center. So take a look at this video, and we'll show you what we're doing about habitat design at NASA. Heather Paul. I've been at NASA since 1994. Welcome to Building 29. So I'm a project engineer on the NASA side with the Advanced Integration Matrix, and as everything at NASA, we have an acronym. So our acronym is AIM. I'm going to take you into the Bioastronautics Laboratory. It is a working laboratory, so I want you guys to be mindful of your heads, the taller gentlemen and ladies. In the event of a fire emergency or anything like that, please keep your screaming to a minimum. I think I've covered it all, so we're going to head on into the facility. This is our laboratory chamber. You may be wondering why our canisters are of this circular shape, because it's not the most efficient use of space. And that's because we figured out that this is approximately what you would fit in the shuttle cargo bay. In real life, we probably would not have a set of stairs right in the middle of your chamber, because once again, not the most efficient use of space. Keep going in and I'll take you into the main connecting tunnel. Oh, sorry, we need to go this way. Got my map upside down. And this is the former biomass production area, so maybe where they'd have their plant growth chambers. So this one gives you a better idea of just how low the ceiling is. We put this floor in because at one point in time they were thinking of doing exercise studies in here. Now this is not necessarily the design for the habitat, and it's been decided and we're ready to go. This is just one concept.
Well, that's about all for our program, but we do have a future of exploration of Mars to talk about real quick. We have a timeline of robotic programs for the future before the human programs. In 2005, we're going to work on an orbiter for Mars, and it'll help map Mars and continue the search for life and water. And then 2007 is the Phoenix Mars Scout mission. It's a polar lander, and the poles are interesting because we think there's water ice there that we can possibly use in future human exploration. Then in 2009, we have a lab rover, and that's going to be a sample return mission, which is going to be very interesting for us because we need to get some soil back. And then in not before 2013, we'll have a geological scout also to do a sample return. Then after that, we're going to get into a mission back to the moon with humans. And finally, in 2030 time frame, we hope to have a human mission to Mars. So that's a future of exploration of Mars. And we hope that you will be involved in it along with us. Thank you.
And all right, we have some more questions. We have one from Hannah from Indiana. Go ahead, Hannah.
Hi, I was wondering what kind of weather is on Mars.
Okay, what kind of weather is on Mars? What do those little rovers have to contend with? John, what kind of weather?
Well, Mars is basically a very cold desert planet. The temperatures are almost always below zero and freezing. But sometimes in the summer, close to the equator, the temperatures can get up to above zero for an hour or two, but then it plummets right back down again. So it's just a cold, dry desert of a planet.
Great. All right, we have another question from Sagar. Sagar, what is your question? Go ahead.
What would happen if you put nitrous oxide in a rover?
What would happen if you put nitrous oxide in a rover? All right, Eddie, you're the rover man. What would happen to that rover?
As a rover man, that sounds like a nightmare. I'm not sure what exactly would happen, but it doesn't sound like something I would want to put in a rover.
Excellent. Okay, thanks.
Okay, our next question is from Sarah from North Carolina. Okay, Sarah, what's your question?
If you could go to Mars right now, what would be the first thing that you would do?
If we could go to Mars right now, what would be the first thing you would do? Laura, what do you think?
I think we'd probably try to go to the ice caps and look see if there's water, and then that would tell us that looking for life is probably around that area. So I think we'd probably look for water first.
Okay.
Okay, our next question is from Brant from Indiana. Okay, go ahead, ask your question. Okay, you can ask your question now.
We can't find Brant.
When we go to Mars, how will we find out if there's still water underneath its surface?
Okay, so when we go to Mars, how are we going to be able to find out if there is water underneath the surface? Do you know that?
Yes, okay. Well, what we've been doing, maybe we could like dig underground and look for rocks that are only formed underwater.
Okay, so it's going to be some of our experiments that are going to determine that. Okay, so we now have another question from Brittany from Arizona. Hey Brittany, what's your question?
Hi, I was wondering how an astronaut would go to the restroom when he's in space.
Oh, how would an astronaut go to the restroom when he or she is in space? You know what? We have an astronaut. I think hopefully we can swing over and ask him that question. How do you go to the bathroom? All right, I'll answer that one for you. The astronauts, when they are up on orbit, they have a bathroom actually in the spacecraft. So it is like what you have on Earth. They have a bathroom, and so it's pretty similar. And we have one more question. Sarah, go ahead. Go ahead, Sarah.
Have plate tectonics occurred on other planets?
Can you please repeat your question?
I got it actually.
Okay.
Have plate tectonics occurred on other planets? Ha 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 ha. Our geology man down at the end, John. Final question.
We don't have any real good evidence to see active plate tectonics like we're experiencing here on Earth right now, but there are landforms on Venus that some people think look like maybe subduction zones, and then of course the big valley on Mars, Valley Marineris, is a rift zone, so that there was something that pushed up on the surface to split it, and that would be considered tectonics, but not in the sense of plate tectonics moving all around like we have here on Earth.
Excellent questions. We want to thank everybody that participated in this show. All of you students out there in your classrooms, the students here at Space Center Houston. We'd love to thank Best Buy's Children Foundation for sponsoring this program, Ball State University for putting on the entire show, and all of you experts that have taken the time to come in and help us with all these questions. Thanks, everybody. Goodbye.
Bye.
My name is Tim Glover. I work at the Johnson Space Center on the VASMR rocket project. I started off as a teenager building rockets myself, and then got a degree in physics in university. I taught high school science for 5 years, and then decided to get a PhD in physics. And during that PhD work, I discovered the VASMR project, and I've been working on it ever since.
Hi, my name is Laura Shaw, and I'm an environmental systems engineer at the NASA Johnson Space Center. I grew up really liking NASA. I watched all the space shuttle launches, and I went to Purdue University and studied mechanical engineering right out of high school. While I was there, I interviewed for the co-op program, which is kind of an internship program, and I got that, and I came here in 1999 and worked as a real engineer for about 4 semesters, and then I was hired on permanently in 2002 in the intervehicular activity flight crew equipment.
Okay, my name's Andrew Abercrombie. I'm from Scotland, and I first got involved with the space program through a student program which brought me here to the Johnson Space Center to spend a couple of weeks looking at the work that scientists and engineers do here to put man into space. So it was through my involvement in student programs that got me excited and interested in spaceflight, and made me decide to pursue a degree in engineering at the University of Edinburgh. That brought me over to the United States to spend a year working in the engineering directorate. I spent a year researching spacecraft navigation systems. After that, I took an interest in life sciences, and I now research the harmful effects of spaceflight on the human body.
Nice work on that field trip.
Oh no, it was all you.
No, you did great. Congratulations.
Congratulations to you.
No, to you.
No, you.
No. Really, you did great.
No, you were the one that did great.
No, you did great.
It was really all you.
No, you did really, really good.
If it weren't for you, this mission would be nothing, really.
No, you did great. You did.
I'm telling you, it's all you.
No, you.
It was you.
It was you.